Alright guys, I have another interesting project here. Basically I'm restoring this bandsaw from DoAll. This is its 2-speed gearbox, so this shaft goes in to go to low gear and out anyway to go to the high gear. I only have one hand because I'm holding the camera with the other one. Anyway, it shifts in and out, and it uses this eccentric round piece on this shift fork, which slides on here to accomplish that goal, which runs off this shaft over here. The problem I'm having is this thing's rather worn. It looks like somebody welded it at some point. The throw for the back and forth isn't far enough, however. I figured the range of motion on this shift fork is 600 thousandths or 0.6 inches, and this thing's not giving me quite that much throw. So I need to make a new eccentric that throws the shaft 600 thousandths in each direction to get positive engagement of the high gear and the low gear. Right now I can get good engagement of low gear, but it just doesn't quite grab on the high. Or vice versa, if I put a washer here, it'll offset it this way. Low gear doesn't really engage, but high gear engages positively. So we're going to turn an eccentric of 500 thousandths diameter on this actual eccentric piece, and this whole thing was an inch originally. I figure I need about 300 thousandths offset, so add that with the 500, we come out to about 1.1 inches of total diameter for this piece here. And we'll drill the backside, put a set screw in it like it had. Then I'll probably taper pin it down the road. I ordered some taper pins. They're not here yet, but I'll have to ream it out and do it on the shaft. Anyway, so by my calculations, this thing is 500 thousandths, so half an inch. I think it was 500. Let me measure it real quick. Just a second. Yeah, it looks like about 500. Yeah, so this is 500 thousandths in diameter right here. So if I need 0.3 over and then add 250 to that, would be 550 times 2. So yeah, I need about 1.1 inches of diameter material to get the half-inch eccentric 300 thousandths over. So what we'll do is put it in a 4-jaw chuck. I'll probably die chem it out, mark it, drill it, then put a rod or something to indicate off of it in the 4-jaw chuck to get it spinning true in the eccentric position, then turn the eccentric. So we'll first start on doing the body that we're going to cut this out of. Just a piece of mystery metal I have laying around here, some scrap. Drill a 5/8 inch hole in the back. I'm going to pretty much copy the rest of the dimensions on this thing and go from there. So meet you back over at the lathe. We'll first spin this down and get the easy work done, which is the back, the whole dimension of this thing, and then I'll show you how I'm going to set it up in the 4-jaw for the eccentric turning. All right, well, welcome back to the lathe. So we got our 3-jaw chuck in here. Just found some scrap material. I don't know what it is. Some probably 1018. I don't know, 12L14 maybe. We'll see how it turns. It's an 1.25 inch material, so the diameter, like you said, is going to be 1.1. So we're gonna take off I don't know, 100 something thousandths of an inch till we're down to 100 over. So anyway, that's what we're gonna do. Just gonna spin this down, and then the whole total part length is about 1.7 inches. So we'll using the DRO to help us out with that. So it's pretty straightforward, nothing too exciting. Once we get our major out diameter for the whole length, we'll then drill our hole and get that drilled in just so the part's all done, and then part it off, take it out, flip it around, chuck it up in the 4-jaw chuck, and I'll show you how I'm going to mark the eccentric, offset for 300 thou, get that dialed in, and then turn our eccentric, and that'll be it. All right, let's get started here. Here we go. Okay. Marking my x-axis now, so I have a good reference to where we're going with this thing. Sorry, I guess you guys can't see that very well with the thing in there. Let me get a better angle here. Okay, we're going to check this real quick and then punch it into our DRO. Welcome back to the surface plate. So what we're going to do is scribe a line for the center point on this part, and then we'll come down 300 thousandths of an inch from the center point and scribe another line perpendicular to the one we do for the center point, and that'll give us our offset for the eccentric that we're going to turn. So this is just slightly under 1.1. It came out to 1 and 97 thousandths, close enough for what I'm doing. So 548 thousandths of an inch is going to be the center point for this part. So I'm just going to dial that in here to our height gauge. 48 right there. So here we go. We'll scribe a line across. That'll be our center point. Got it. So now if I subtract 300 thousandths from the 548, we get 248. So I'm going to dial our height gauge into 248, so that'll be the 300 thousandths offset. So here we go. $100, $200, $248. Close enough. And put this at approximately perpendicular. If you wanted this dead nuts on, I guess you could put it in a in a collet block. I just need to get close. This isn't super precision. It's just for that transmission thing. But anyway, now you can see our scribed lines here. See if this will focus. Come on. Anyway, we're going to center punch that point and then meet you back over at the lathe, and we'll line it up. All right. So basically I've put the part in here with the center punch, then put a dead center into the center punch, into the back of another dead center in the tailstock. And so what we're doing now is lining it up off of our dial indicator on the edge here. So we're just going to finish getting that dialed in, and then we'll be able to turn our eccentric. So we'll come back once this is all finished. We're close already, as you can see on the indicator here. Then about 1.5 thousandths. So I'll just play with it a little bit off camera, get it to where it needs to be, and go from there. So this is a neat way to kind of be able to still use your indicator for a part without the part being concentric in your 4-jaw chug. All right, not sure where, I think I read that in a Richard Hall book from the Home Workshop Library. All right. Okay, so it's now dialed in within about 3/10, close enough for what we're doing. So I'll turn this on so you can kind of see what we're talking about. Notice our center punch point is staying exactly circular, so that's the point we're going to be turning. So now we're just going to start turning this down. It's going to be an interrupted cut for a little bit. So I'll bring you back halfway through so you can kind of see what's happening. So anyway, here we go. I need to be prudent to mark where your furthest point of the throw is, just so we know we're not going to take too deep a cut here. So that's what I'm doing right now. Just kind of seeing right where it's going to be. That's furthest point out. So now we'll just start taking 30 to 40 thousandths off each revolution, and the prescribed z-axis toward the parts. Okay, here we go. We're back again. And start moving in. see where we're at here. We're getting closer. Still got a little flat spot. You can kind of see it here in our eccentric. We gotta get that to actually try and pull around, but it's going along pretty well so far. So we're about 655. So got another 150 to go. So it's 585. So I'm going to update the DRO. All right, there we go. Finish this up creeping up on it right now. With one final measurement. DRO says she got 513, so we'll see where we're at. We're probably a little over that, I imagine. Not the end of the world. Actually dead on the money, so 514, 1,000 off from what the DRO says, so that's not terrible. Alright, here we go. Let's finish this up. Let's take our fast cut here. Alright, that's looking pretty good. Let me get the shift fork and see how that fits. So basically this thing's going to just fit right over. Yeah, it fits nicely. That'll work great. Well, that's about it. I'm just going to face off the front here, clean that up a little bit, and that's all there was to turning an eccentric in your 4-jaw chuck. You saw how I indicated it, just using a dead center backed into another dead center, and then center punching where you want your eccentric, and then just using your dial indicator to kind of dial it in. Pretty straightforward, actually. Face this off here, get a little bit of center punch. I'm just going to chamfer the edge a little bit just to make it nice. And then we'll clean up on the outside, on the shoulder a little bit, because I actually overshot a little bit. Slow this down. This is high-speed steel. Threading tool. go back to our main cutting tool here and we'll just finish up this shoulder. Alright, that's it. You can see it's pretty much cleaned up. A little chamfer on there. That's our eccentric. Let's pop it out, take a look. You guys can see what you think. That's about all I got for this project. I didn't see much on YouTube about how to do this, so I thought I'd take it upon myself to just make a quick video about it. So there it is. There's our eccentric. Like I said, that's going to work great, I think, for what we need it to do. Now I'll take it over to the mill, drill it, tap it. The rest you don't really need to see. This is the original part right here. You can see they're very similar, but I've moved it off a little more to give me more further throw for the gear shift. So, all right, that's it, guys. Thanks.